All right, let's see, 210 miles. Interesting, okay. All right, it's after 9 o'clock, so let's go ahead and do that. So we've got two cities that are 400 miles apart, and a map has a scale of 1 to 50. And we want to know what is the distance on the map. Okay, so what's the story about?
The distance between two cities.
Okay, what can we count or measure?
The two cities and the 400 miles.
Okay, 400 miles. Anything else we can count or measure?
The 1 and the 50?
Yeah, is that important?
Yes.
Okay, whoops, 50 miles. I left out the miles part. Okay, so what strategy do you think we could use? Well, what are they asking us to find?
What's the distance between the two cities in the map?
On the map. Okay, so if you told me miles, were you already wrong? Okay, does an answer of 800, 8,000, do those even make sense?
I'm pretty sure 8,000 makes sense.
It does? Okay, all right, let's look at it. So strategy, what kind of strategy do you want to use? What kind of tool do you want to use to solve this?
400 times 8 because it says 1 into 50. It maps has a scale of 1 into 50.
Let's see. If we do the drawing and the actual, we know that 1 inch is 50 miles. Okay, where am I going to put that 400 miles?
We're going to multiply it by 50.
No, you're not.
Oh.
Okay, I'm going to put that 400 underneath the 50. Okay, so now my question is, how do I get from 50 to 400? I multiply it by, what's 400 divided by 50? Well, I can cancel out the 10, so what's
8.
8? So how many inches is it on the map?
8.
8 inches. Okay? So those of you that told me miles, you didn't look at what the question asked. Okay? Those of you that only told me 8, you need to tell me 8 inches so I know what unit you're talking about. All right? We don't always multiply by 50 or by the scale factor, Jahan. You got to think about what they gave you, okay? In this case, we divided by 50.
I thought it just said in, not inches.
Yeah. So you got to be careful, which is why I like using the table, because the table sets it up for me to know which way to go. Okay? All right. So I'm hoping that you watch the video. Whoops. Okay, of lesson 2, introducing proportional relationships with tables. That's what we're starting with today. And yes, we skipped lesson 1, did that on purpose. So our learning goal is, let's solve problems involving proportional relationships using tables. Okay, we used tables when we were doing scale factor, so we're going to continue with those tables.
Miss Laird.
Yeah.
That gif of that old man
Uh-huh.
unfolding a bench into a table, is that an actual product?
Uh-huh. It sure is.
Dang.
Okay.
I'd actually want that. I
Yeah.
need to invest in that.
All right. So our goals for today are I understand these terms, proportional relationships, and constant of proportionality, which we will call the COP. I can use a table to reason about two quantities that are in a proportional relationship. So let's start out with those terms. If you watch the video, I did define those terms, but let's just go over that. Oh, there's another GIF. Okay. All right. So what is a proportional relationship? Anybody remember from the video? Okay.
Are they relationships? Aren't they relationships like between two variables?
Two
Where
quantities. Uh-huh.
yeah, where their ratios are equivalent.
Yes. Good.
Basically,
Ratios.
is this just an equivalent ratios?
It is. We are building on what you learned in sixth grade about equivalent ratios. And those equivalent ratios are when you have equivalent ratios, we say they are in a proportional relationship. Okay, so when two quantities are always in equivalent ratios, so the relationship in that problem that you did with the cups of rice and the number of people, remember the 3 or the 1 cup of rice served 3 people. Okay, this is a proportional relationship between the 3 and the 1. 3 people served 1 cup or were served with 1 cup of rice. That
Is
is
it also
go ahead.
is it also just the the similarities in tables?
Yeah, when we look at tables, if you remember from when we did it in the lesson, we could look at it going down like we did with scale factor, but now we're looking at the relationship going across, okay? And that relationship, if it's multiplied, if one number is multiplied by the same number to get the other number, and every single one of them is multiplied by that constant, that is our constant of proportionality. That's our multiplier. So any constant ratio, and remember unit rates from sixth grade? Okay, that 3 people being served by 1 cup of rice is a unit rate. 1 cup of rice serves 3 people. So that constant is going to be 3 in that case, because if I have 2 cups of rice, I'm going to multiply 2 times 3 to get 6 people that it will feed. It can always be found by finding how much of the second quantity per one of the first quantity. And what did I do in the tables when I did that? Do you remember what I added to the table? Did I add that?
Factor?
I added that third column, didn't I, with y over x? And that y over x found the constant of proportionality. So in that bread dough activity, when I did y over x, I got 1.25. And what that means is I'm going to multiply any amount of honey by 1.25 to find the amount of flour that was needed. All right, did that make sense to you when you did the activity? I'm getting the feeling that not many of you watched the video. The only way this is going to work is if you watch the videos ahead of time, because I'm going to refer back to them. All right, so we are going to do the practice problems now. So what I want you to do is go to the lesson page in Canvas and click on the PDF. So you've got it up. And if you'll split screen so that you can see the Zoom meeting as well as the PDF. Or if you just want to follow along with what I'm doing on the screen here, that'll work as well. All right. Anybody need more time? Nobody needs more time.
I,
You do? Okay, I'll give you a minute to find the PDF or to get a piece of paper. However you want to do it, whatever makes it easiest for you.
Wait, how do you split screen?
Somebody said you go down to the bottom and you should have 3 apps down, the only apps that you have open, and you can click on them and it will split screen it. Maybe that's something you'll need to Google and figure out.
What I do is I put the app I want to use at the bottom in the little app place on the bottom, and then drag it to the side of the screen.
Okay, let you share your screen, Liam.
Oh, I figured it out.
Oh, you figured it out? Okay.
Yeah.
All right, I'll go back to sharing my screen then. All right, I'm trying this a different way. So I'm sharing my screen. Can you all also see where I'm going to write on the TV? Or do I need to stop sharing my screen? Would that be better?
Yeah, I can't really see
Okay.
it.
All right, I'll stop sharing my screen. I don't know how it comes across to y'all.
wait, so we're looking for the practice problems PDF or the activity?
No, you should have already done the activities. That was your assignment to do before you came to class. So now we are doing the practice problems.
Ooh.
All right, so practice problem number 1. It's kind of wordy, so it may be hard to see here, which is why I want you to have it in front of you. It says, when Han makes chocolate milk, he mixes 2 cups of milk with 3 tablespoons of chocolate syrup. Here is a table that shows how to make batches of different sizes. It says, use the information in the table to complete the statements. Some terms are used more than once, okay? So this table shows a proportional relationship between what and what?
2 and 3?
No.
Or are we talking about the
Here's
agree-
our terms that we can use.
Cups and tablespoons?
Cups of milk and tablespoons of honey. Isn't that the relationship between? Isn't that what the relationship is?
yes, and that's chocolate
Yeah.
syrup.
Okay, so cups of milk and tablespoons of chocolate syrup. So that's the relationship that's shown in the table. All right. The scale factor shown is what?
4?
4. Okay. What is the constant of proportionality? What is everything multiplied by? So we're going to add on to this table, we're going to add a y over x. Okay. So this is x and this is y. Can you all see that? Okay. So we're going to take y over x. That's going to be 3 over 2. And we can leave it as a fraction. Or we can simplify it, which would be 1.5. Okay. Do we get the same thing here? What's 12 over 8? Well, 12 over 8 reduces to 3 over 2, which we know is 1.5. 3 over 2 over 1 is 3 over 2. And 15 over 10 ends up being 3 over 2. So what is our COP? What is our constant of proportionality? What did each one of these get multiplied by to get the other answer?
3 over 2?
3 over 2. So our constant of proportionality is 3/2. And what that means is 3/2 of a tablespoon of chocolate syrup for 1 cup of milk. Your COP is going to occur when X is 1. Okay, the units for the constant of proportionality are
Tablespoons and cups.
tablespoons.
Or do they have to be the other way around?
Nope, you're right, of chocolate syrup per cup of milk. Because we had to use these terms down here. Okay, so it's the number of tablespoons of chocolate syrup per cup of milk. That's what the constant of proportionality is telling us. That it's going to take 3/2 tablespoons of chocolate syrup to make in 1 cup of milk. Okay, questions you have about that problem? All right, anybody need more time?
Yes.
Okay, I'll give you more time. Okay, are we good? All right. Problem 2, a certain shade of pink is created by adding 3 cups of red paint to 7 cups of white paint. How many cups of red paint should be added to 1 cup of white paint? And what is the constant of proportionality? So what is this story about?
Paint.
How much it takes to make paint?
Right? What can we countermeasure? What do we know?
1 and there's 1 for white cups of paint. There's none compared to red paint for now.
Okay.
And 7 white paint and 3 red paint makes pink paint.
Right. Okay. All right. And we're being asked to find how many cups of red paint for 1 cup of white paint. Okay. Because this is a proportional relationship, because it has to be done in the same ratio to get the same shade of pink, we are going to think about the constant of proportionality. To get the constant of proportionality, we are going to add that y over x over here column. Okay, we don't know this right now, but we know this right here. This is x and this is y. So we're going to put 3/7 and we're going to leave it as a fraction. What that's saying is to get from here to here, I multiplied it by 3/7. Right? 7 times 3/7, does that equal 3? Okay, because they are in a proportional relationship, then I am going to multiply this by 3/7 to find out that. So what is 1 times 3/7?
3/7.
3/7. So when I have 1 cup of white paint, I need 3/7 cups of red paint to make that shade of pink. All right. What is the constant of proportionality? What was the thing that we multiplied everything by?
3/7.
3/7. That is our COP. Okay, if you add that y/x column, that is going to give you your COP. And that is your multiplier when you are going from left to right. Questions you have for me?
So what is it?
What is what? What is the COP?
Yeah.
The COP is the multiplier. When I do y/x, I get 3/7 here. So I know that each of these are going to be, every x is going to be multiplied by 3/7 to get the y. And we know that because we are making a certain shade of pink and it's in a proportional relationship. If you don't have the same ratio of white and red, you aren't going to get the same shade of pink.
Okay.
Okay? Any other questions you have for me?
I have a question.
Yes, Liam.
Will the formula always be for finding a missing part of the table always be the bottom 2 rows, or will it?
It can be anywhere in the table, but they have to give you, you have to have one relationship.
Okay.
Okay, they have to give you one relationship so that you can see what the equivalent ratios are.
All right.
All
Thank
right?
you.
You're welcome. You got to find that COP. Okay? Anybody need more time? Anybody got more questions? All right, I guess I can erase them. All right, on to problem 3. A map of a rectangular park has a length of 4 inches and a width of 6 inches. It uses a scale of 1 inch for every 30 miles. We are being asked to find the actual area of the park, and then we want to reproduce it at a different scale so it will fit in a brochure. So what is this problem about?
The size of a park.
Okay, we got a park, and we know it's a rectangular park, right? What can we countermeasure?
4, 6, and 30.
A length of 4 inches, a width of 6 inches, and 1 inch for every 30 miles, okay? Let's start with A. We want to know the actual area of the park. Would a picture help to get us started? I think so. So I'm going to draw a picture. Probably didn't draw it right, but that's okay. We're going to call this 4 inches because that's the smaller side, and this is 6 inches. Okay. Now what? Well, we got a
Multiply
picture.
6 and 4.
Can we do a table maybe? Okay. So we're going to have drawing and actual. And we know 1 inch on the drawing represents 30 miles of the actual. Okay, so can I take this 4 inch and figure out how many miles that is?
Yes.
I want to know the actual area of the park. So to find the actual area of the park, I'm going to need to multiply the length times the width, right? Okay, so I'm going to put 4 inches right here. How do I get from 1 to 4?
Multiply by 4.
So I'm going to take that 30
That
and
equals 120.
4. So this is 120 miles in real life. Okay, can I do the same thing with the 6? So if I put
Yes.
6 inches here, how do I get from 1 to 6? I multiply by 6.
6.
So now I'm going to take 30 and multiply it by 6. And that's going to give me That's 6 times 3. 18, and 6 times 30 would be 180. So this side is 180 miles. Okay, so how am I going to find the actual area of the park knowing that information?
Multiply 120 by 180.
Okay, so get out your handy dandy calculators.
I already did it. I already calculated it.
What you get?
21,600.
I'd have to look back at it. Give me a second.
21,600, I heard.
Yep.
What's the unit
That's
distance?
it.
Miles squared. All right. Now we want to reproduce the map at a different scale so that it has an area of 6 square inches and can fit in a brochure. At what scale should the map be reproduced so that it fits on the brochure? Well, what's the area of it right now? All right, let's go to here then. It needs to have an area of 6 square inches. So what could the two sides be? The area has to be 6 inches.
3 and 2.
3 and 2. Okay, so let's try 3 and 2. Okay, so if we want it to fit, let's see, what do we know? Well, we know 3 has to be 180, right? 3 inches is going to have to represent 180 inches, right?
Yes, ma'am.
Okay, and we want it in a scale, so we want this to be 1 inch. So what do I do here? Whoops, let's go the other way. What do I do here to get from 3 inches to 1 inch?
Divide by 3.
Okay, we can divide by 3. So what am I going to do to this?
Divide by 3.
Divide by 3. So 180 divided by 3 is
60.
60. So what's the scale I need? 1 inch represents
3.
60.
Oh, 60.
60 miles. Let's see if it works with the 2 side. So we have 2 inches. Let's see if we get the same scale. 2 inches is going to have to represent 120 miles, right? Okay, I want to know what is 1 inch going to represent. How do I get from 2 to 1?
Divide by 2.
Divide by 2. So if I take this and divide it by 2, what do I get?
60.
60. So do I get the same scale?
Yes.
Yes, so that's the scale I need. I need 1 inch to 60 miles to fit in the brochure. Okay, who does not understand what I did? Okay, who needs more time?
Me.
Okay. All right, are we good? Or you still need more time?
I'm good.
Okay. All right, on to problem 4. Problem 4 says Noah drew a scaled copy of polygon P and labeled it polygon Q. If the area of polygon P is 5 square units, what scale factor did Noah apply to polygon P to create polygon Q? So we have polygon P and we know its area is 5 units squared. And we want to know what is the scale factor. So what was our scale factor to go from P to Q? That's what we want to know. Okay, is our scale factor going to be bigger than 1 or less than 1?
Bigger.
Bigger than
Bigger.
1 because the picture's going from small to big. Okay, do we need to figure out what the area of Q is? Would that help us to know that information?
Yes.
Because what do we know? We know original area times what equals the copy area. How do we find the copy area if we know the original area and we know the scale factor? What do we do? Some of us got this wrong on the test. Scale factor squared. Okay, so what is the area of Q? How can I find the area of Q? Give me a strategy. I can't do length times width.
You could count the cubes.
I could count the cubes. Is there an easier way?
I would
Break
count.
the shape down into smaller shapes.
Yeah.
Okay, so if I drew lines there, now I've got 2 rectangles and a square.
Yes.
You could also do the line down.
Could I also do the line going
Yeah, like
that
that.
way? All right, either way works. Or I could do, oh look, what do I end up with?
4 squares. I mean 5 squares.
5 exact squares, don't I? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 5 is,
45.
so this has an area of 45 units squared. Okay, so how many times bigger is the area?
9.
9 times bigger. Is the scale factor 9?
Yes. Nine squared.
18.
The area is 9 times bigger. So the original area, 5, was multiplied by 9 to get the new area. But I want to know what is the scale factor. So don't I need to know what times what equals 9?
3.
3. So what is the scale factor?
3.
3. Because the area is 9 times bigger, the scale factor is 3. All right, how do we feel about that? Good, okay, I saw some thumbs up. Any questions? Okay, who needs more time? All right. I hope you're writing these down. All right, question 5. Select all the ratios that are equivalent to each other. All right, so if I write this as a fraction, this is 4/7. This is 8/15. Can I reduce 4/7?
No.
No. Can I reduce 8/15?
No.
Okay.
Um.
How did you all learn to determine if they were equivalent ratios? What did you do in 6th grade? Do you remember?
Well, we didn't turn it into fractions. I don't remember what we did though, but I know we didn't turn it into fractions.
Okay. Well, let's see if turning it into fractions works. 16/28. Does that reduce?
Yes.
Okay, so 4 goes into both of them. So that ends up being 4/7. Are these two equivalent?
Yes.
Yes, okay. How about 2/3? Does that reduce?
No.
No. How about 20 over 35?
Yes.
Okay, looks like 5 goes into both of them. So
Mhm.
does that reduce to the same thing? Yep. So A, C, and D. Okay. Another way to do it is you can take and write it as a fraction and then see if the cross product equals each other. So that's where a calculator is handy. And what I mean by cross product, if I multiply 28 times 4, I get 112. If I multiply 7 times 16, I get 112. So is the cross product equivalent?
Yes.
Okay. So that's another way to determine if two ratios are equivalent. Another way is to look at them. So we've got 4/7 and 20/35. Is there a number that I can multiply both of these by to get that? Well, 5
Yes.
times 5 gives us 20 times 5. And this is really 1. Can I multiply anything by 1 and it doesn't change its value?
Yes.
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 So this would be equivalent because I multiplied it by 1, but I just put it in 35ths instead of 7ths. Okay, so that's another way to tell if they're equivalent. So we can reduce the fraction, we can check the cross product, or we can see if it's multiplied by the same thing. All right, questions?
No.
All right, guess what? You are finished with lesson 2. I have a couple things to go over. If you took the test, I have graded all of the ones that I got as of 8 o'clock this morning. Now you can go in and do the reflection of the test because you couldn't do the reflection until you knew your score. So you can go in and do that. I need you to check your Power School and to make sure you don't have any grades lower than a 50, because I know on the practice problems, it will give you a grade less than a 50, but I need to go in and give you the 55 because you turned in something, okay? If you are not happy with your test grade, you can rework your test. I'm going to make a video tonight of me working all the test problems. So you will rework it and I will give you instructions on how to do that. You'll submit your rework and then you can retest and I'll have that up by Wednesday. So what I'm gonna do is I'm gonna create a module called Unit 1 Retest Module, and it'll have a place for you to turn in your rework, and then it'll have the test to retake. Okay? I'll have that done by Wednesday. All right, any questions you have for me about Unit 2, Lesson 2? Okay, do we understand?
Yes.
Yes.